Something extraordinary is happening in astronomy right now. The James Webb Space Telescope has just uncovered galaxies that appear to exist before the universe should have allowed them to form. Massive structures shining brightly when cosmic time itself was barely underway. Systems so mature and luminous that they defy the very timeline of reality as we understand it. In recent observations, Webb has confirmed a galaxy seen just 280 million years after the Big Bang, detected unexpectedly strong light breaking through the early cosmic fog, revealed compact red sources hiding over massive black holes, and found chemical complexity in environments far too primitive for such riches. At the same time, Webb is peering into the deepest recesses of cosmic dawn, exposing galaxies far more abundant, far brighter, and far more evolved than any model permitted. This isn't merely about distant lights in the sky. These findings are compelling scientists to confront profound dilemmas. Are our timelines flawed? Did massive galaxies and supermassive black holes assemble in ways we never imagined? And are we witnessing evidence that the universe's infancy was not a slow, tentative awakening, but a rapid, explosive surge of creation? Tonight you are about to discover how Webb's latest revelations, from the farthest known galaxy to hidden monsters in the dawn, are challenging the very notion of cosmic time itself. The universe Webb is unveiling does not align with the chronology our theories demanded. According to the standard cosmological framework, the cosmos emerged 13.8 billion years ago from a searing, uniform plasma, expanding and cooling ever since. In those first moments, no stars existed, no galaxies, only a featureless sea of hydrogen and helium shrouded in opacity. Light could not travel freely until roughly 380,000 years later, when the universe cooled enough for atoms to form, releasing the cosmic microwave background we detect today. But true illumination began much later, during the epoch of ionization, when the first stars and galaxies ionized the surrounding gas, clearing the fog over hundreds of millions of years. Astronomers measure distance and age through redshift. As space expands, light from remote objects stretches toward longer, redder wavelengths. Higher redshift means greater distance, looking further back in time. This redshift acts as our cosmic clock, turning deep observations into windows on the past. Yet for decades, there was a firm boundary to how far this clock could wind back. Previous telescopes glimpsed galaxies up to redshift 11, corresponding to about 400 million years after the Big Bang. Beyond that, theorists expected a sparse, underdeveloped cosmos, with galaxy formation only beginning in earnest. Then the James Webb Space Telescope turned its mirrors toward the abyss. Designed to capture the faintest infrared whispers from the earliest epochs, Webb shattered that boundary almost immediately. Where emptiness was predicted, it found a crowded sky. Galaxies emerged at redshifts exceeding 13, some at 14 and beyond, visible when the universe was less than 300 million years old. One standout, confirmed through meticulous spectroscopy, exists at a redshift placing it just 280 million years after the Big Bang, the current record holder for the most distant known galaxy. This object is not a faint speck, but intrinsically bright, spanning thousands of light years, powered predominantly by young stars rather than hidden activity. Its existence alone strains the clock. In such brief cosmic time, gravity should have barely begun clustering matter into substantial structures. Yet here it stands, fully formed and radiant. Even more unsettling than their distance is their sheer abundance and maturity. Webb's deep fields reveal dozens, even hundreds of such high redshift galaxies, far more than simulations anticipated. Many are not fragile protosystems, but robust, with stellar masses rivaling modern spirals, assembled in a fraction of the expected time frame. Some appear ultra-compact, yet extraordinarily luminous, dubbed blue monsters for their intense star formation without the dust veils common in later eras. Others manifest as little red dots, tiny crimson points that initial analyses suggested were impossibly massive galaxies. Deeper scrutiny revealed many harbor actively accreting supermassive black holes, their fierce energy obscured by dust, inflating apparent brightness and size. These black holes, millions to billions of times the Sun's mass, dominate their hosts, growing at rates that outpace galaxy assembly itself. In one remarkable case, a galaxy observed around 800 million years post-Big Bang hides a central beast far larger than its stellar content should sustain, a shapeshifter appearing ordinary in shorter wavelengths, but monstrous in infrared. As Webb delved further, it uncovered signs that the early universe was clearing its primordial fog far sooner than foreseen. In a galaxy at redshift 13, seen merely 330 million years after the Big Bang, bright Lyman alpha emission from hydrogen pierced through what should have been dense neutral gas. This emission, strong and unmistakable, implies pockets of ionized bubbles forming early, driven by vigorous starbirth or black hole activity. The fog of cosmic dawn was parting unexpectedly fast, allowing light to escape where models predicted prolonged darkness. This accelerates the reionization timeline, suggesting the first generations of stars and galaxies were exceptionally efficient at producing ionizing photons. And then Webb exposed unexpected chemical sophistication in these fledgling worlds. In primitive dwarf systems mimicking early conditions, it detected rare dust species and carbon-rich molecules where heavy elements were thought too scarce. Nearby analogs revealed dust production far exceeding predictions, hinting that the building blocks of complexity, silicates, organics, metals, emerged rapidly. Distant counterparts show oxygen and other elements in abundances, implying explosive enrichment from early supernova or unconventional pathways. One of the farthest galaxies, bright and extended, harbors chemistry that should require billions of years of stellar processing. These discoveries indicate the infant universe was not barren but fertile, seeding the ingredients for planets and life almost from the outset. While these galaxies rewrite formation histories, Webb also illuminates hidden dynamics challenging growth models. Turbulent gas motions dominate many young systems, clumpy and chaotic, delaying the settled disks we see today. Gravitational instabilities and feedback from stars stir relentless upheaval. Yet somehow order emerges swiftly. Compact sources reveal black holes leading the charge, accreting voraciously and perhaps seeding galaxies rather than following them. Overmassive examples suggest direct collapse from pristine clouds, bypassing gradual buildup. Little red dots, once feared as universe breakers, now resolve into these black hole-dominated oddities, easing some tensions but highlighting others. Galaxies still form brighter and more numerous than pre-Webb forecasts. This is where the challenge to cosmic time grows acute. These structures appear too evolved for their epoch. Dark matter halos, the supposed scaffolds, should not yet support such masses. Star formation efficiency must have been near perfect, converting gas to stars at unprecedented rates. Black holes grew too swiftly, defying accretion limits. Some speculate exotic mechanisms. Dark stars powered by annihilating dark matter, altered initial conditions, or bursty episodes amplified by feedback. Others revisit foundational assumptions, probing whether expansion history or fundamental physics differs in the dawn. Yet the core framework endures, refined rather than overturned, as new data reconciles extremes. According to emerging analyses, the early universe was not a gradual build, but a frenzied rush. Galaxies ignited faster, black holes surged ahead, chemistry flourished amid chaos, and light banished darkness prematurely. Webb keeps pushing boundaries, each dataset hinting at deeper surprises. What is undeniable is this: the cosmos's earliest moments were not tentative or sparse. They were vibrant, overcrowded, prodigiously creative, defying the measured pace we once envisioned. Thanks to Webb, we are not simply mapping distant realms, we are confronting the limits of time itself. And this revelation has only begun. What secrets still hide in those ancient lights? How profoundly might our story of origins shift next? Pause and ponder the vastness you now glimpse. The universe, in its youth, already outpacing our imagination. If this journey through cosmic dawn has stirred wonder in you, subscribe for more explorations of the unfolding cosmos. Leave a comment with your thoughts on these impossible galaxies. Share this with someone who needs to feel the awe of discovery, and let these revelations linger, reminding us how much remains to be understood about the reality we inhabit.